Okay, sir.
Good morning, dear participants. Today we are very much fortunate to have Professor Tanmay Mohanty, Senior Professor at School of Mechanical Engineering, KIIT University. Uh, as a teacher, he always says me, teaching remains as a piece of information unless it is being implemented to be transformed as knowledge. So I also believe in that. Today we are trying to make an attempt to start with the concept of ANN modeling using Excel, and then we'll try to implement it by solving few practical problems. We'll be using Excel, so it will be better if you use your laptop for this session. Uh, so let us start it. Biren sir, can you please play the video?
Good morning, my esteemed teachers and colleagues, scholars and participants of this workshop. Optimization tools in manufacturing process, OTMP 2020, KIIT sponsored online class. In this session, we shall be discussing on ANN modeling using Excel. ANN modeling is artificial neural network modeling using Excel. We shall be going through this particular topic in three different sessions in this workshop. In part 1, we shall be discussing the concepts of artificial neural network. In part 2, we shall be using those concepts in Excel programming of an artificial neural network. And in the third part, we shall be interacting wherein we shall be discussing on your queries. At the end of this session, we are expecting that the participants will be able to develop a ANN model using Excel on their research data, if they are interested to take up that. So to start with, let us discuss one problem, research problem, related to manufacturing engineering. This research problem was solved by one of my faculty colleagues. The statement was, during erosion test of certain composite, as we know, composites can be manufactured using different ingredients. This particular composite, what my faculty colleague proved, consisted of rice husk. Okay. During the erosion test of this composite, we obtained erosion rate in milligram per kilogram of specimen. Okay. The experiments were designed so that we could vary the content of rice husk in the composite, the improvement angle at which the reduction is improved, the impact velocity, at what velocity the reduction strikes that composite, and the erosion size, the size of the particles that will erode that composite. Our inputs were rice husk content, improvement angle, impact velocity, and erosion size. And what we got is erosion rate in the composite. Our task in the research is to formulate a function that relates the output, that is the erosion rate, with respect to the indeterminate variable. These indeterminate variable like rice husk content, improvement angle, impact velocity, and erosion size. Okay. This is the problem statement, and this we shall be using as a case study for this modeling through artificial neural network. let me start with the data sheet that we generated during the experiment. The design of experiment consisted of 16 norms, where velocity of impact was an independent variable, and this impingement angle is a variable, the rhesus content is a variable, and erosion size is also a variable. The velocity of impact was varied like 30 meter per second, 40 meter per second, 50 meter per second, 60 meter per second. Similarly, the rhesus contained in the composites that they were tested were 0%, 5%, 10%, 15%. The impingement angle that were selected for these experiments at 45 degree, 60 degree, 75 degree, and 90 degree. And the erosion size was 40 micron, 60 micron, 80 micron, and 100 micron. And the erosion rate that were obtained in the experimentation is put here in this output of R. Okay. So you can see we have noted these inputs as A, B, A for velocity of impact, B for rhesus content, C for impingement velocity, and D for erosion size. And the output in the experiment is erosion rate, that is in R, that we have denoted using the letter R, the unit is milligram per kg, MD per kg. Okay. We want to formulate the relationship. Our ability is to develop a function that relates this R, erosion rate, as a function of the input parameters, the velocity of impact, the rhesus content, impingement velocity, and erosion size. Now, in artificial network, neural network, our objective is we want to develop a function so that we can find out for a given set of the input parameters, A, B, C, D. As we have discussed already, we have taken A or B rhesus content at 0%, 5%, 10%, 15%. Suppose I want to measure what will be my erosion rate if I take 12% of rhesus. What is the value of R for a given value of A or B or C or D? That is one thing we can predict if we can develop this function R. Okay. In what way that will be beneficial? For a variable rhesus content, suppose you want to go on varying, say, rhesus by 1%, 2%, 3%, 4%, you can understand the number of experiments that will be required will be time intensive, cost intensive, and very practically not feasible. Okay. So in that case, this type of mathematical model development helps us to predict the value of the erosion rate for a particular value of B or A or C or D, whatever input parameter we do. This type of model can help us. Another way it can help is for what combination of A, B, C, D, for what rhesus content, for what impingement angle, like that, from a set of input conditions, this R is optimum, erosion rate is optimum. Okay. How significant is the contribution of each variable to this erosion rate? Whether the contribution of rhesus is more than the velocity of impact, or contribution of eroded size is more than rhesus content, something like that. Whose contribution is more on the erosion rate? And in a manufacturing research, these things carry a lot of significance to find out at what particular combination we can have a minimum erosion rate. If I change some percentage of rhesus, will the erosion rate be within acceptable limit in terms of quality? No, not only in manufacturing research, in any particular research. Say during this pandemic of COVID also, people have been generating different models. If temperature of a particular location goes up, whether spread of corona will be up or low. How do you know? By some sort of mathematical modeling. this artificial neural network will be giving us a model, will be generating function kind of thing, where one output will be related to the inputs. And you must keep in mind that this type of function is a non-linear function. You know that a linear function means, suppose I tell y is a linear function of x, that means y equal to mx plus c, y is directly proportional to x. If x gets multiplied by 2, y also gets multiplied by 2. Similarly, or if there is an intercept, then y and x will form a straight line. But in this particular case, in manufacturing process research, erosion rate will it be directly proportional to your ISS content? There is no theoretical development as such. Okay. When we do not have theoretical development which predict a particular functional relation between output and input, such type of modeling can be extremely helpful provided we have got quite a significant number of experimental data. We have got experimental data that furnishes the changing values of A, B, C, D and the output that we get. Then we can develop a mathematical model through using this artificial neural network to predict what will be the output for a given set of A, B, C, D. Okay. Now, how we go for this artificial neural network? We start categorizing our data into 3 different stages. One is learning, V for validating, T for testing. Learning, validating and testing. This classification is to be done on the data, and that's what we are going to do once you understand what are these learning, validation and testing. See, I belong to an area which is devoid of these rivers. Basically, we live in a flat area where we have to move around 30 kilometers to reach a river or 10 kilometers to reach a pond. And as you can particularly relate with me if you have been staying in similar location, in these type of locations, learning to swim is very difficult. Okay. I myself, when I teach fluid mechanics, we also help students to understand the mechanics of swimming. So here in this diagram you can see one person is swimming. There is a weight which is downward. Also this fluid, this body is partially immersed in the fluid, therefore fluid exerts a force of buoyancy. Okay. Now, for a particular person to float on the water surface, weight should be equal to buoyancy. Buoyancy, you remember, this is the weight of displaced fluid. So we tell in our lectures that you displace fluid so much that weight of that displaced fluid will be either equal to your weight or more than your weight so that you can float. Okay. Similarly, when a person moves in a direction during swimming, there is a backward force, drag, that is a resisting force, and when we apply our thrust, we apply thrust kind of motion so that we can move forward. This thrust and drag are also to balance. See, I am quite lovely to understand how swimming works, but this is what you can call putrika jnana, book knowledge. I do not know how to swim. I know that if buoyancy will be equal to weight, I will be able to float. Drag will be equal to thrust. I will remain at that position. If thrust will be more, I can move forward. I know a lot of things. But is this real learning? In the schools and colleges, when we teachers talk to the scholars and candidates, we only have means of education. We do not give education. This, whatever we are providing, is a piece of information, and the learning happens, the true education happens when that is validated. Validated by the scholars themselves who are learning these things. Okay. In artificial neural network modeling also, the model has to learn and the model need be validated, model need be tested. These things are very essential, for which the entire data set is categorized. Which data will be taken for running, which data will be taken for validating, which data we shall be taking for testing. Okay? Now, there is a thumb rule kind of thing. There is no specific guideline that this much data will be for training or this much data will be for validating, this much data will be for testing. There is a thumb rule kind of thing. If we are handling less number of data, then 70% for training, okay, 20% for validating, 10% for testing. Testing means, one should develop an artificial neural network model, one should develop. This developed neural model will be based on this data set, which is used for learning. And once that model is developed, that will be validated taking this set of data, second set of data, marked by these red lines. After that, the testing of the model also need to be tested. Whether model, what is the accuracy of the model, what is the sensitivity of the model, what is the specificity of the model, that need to be tested. And in order to do that, we are also to categorize a set of data which will be used during testing of the model to know whether we are really being able to develop a model. When we shall develop a model, we shall be taking the data that will be categorized for learning, this stage. Eligibility, learning, validating, testing. A set of data will be taken for learning. If we are handling a large number of data, then it is prescribed that take 90% of data for learning. More the learning, the artificial neural network, this entire mechanism works like the model runs itself. Model runs itself. If you give more data, then the learning will be more effective. That's how it is prescribed. If you are handling large number of data, this artificial neural network finds huge application in different fields, not only restricted to manufacturing process. We are going to see some of the application area also. Where we handle a significant large amount of data. Then it is prescribed that take 90% data for learning, 5% data for validation, 5% data for testing. If we are handling small number of data, like in this particular research we are taking only 16 set of data, that is a very, very small number of data in terms of artificial neural network, and it is prescribed take 70% for learning and 20% for validating and 10% for testing. That will be adequate. Okay. Now, once we categorize for learning, for validating, for testing, while in our learning stage, we have already categorized the digital data we shall be take for learning. Our job starts with assign weightage to the input. There are inputs in our research question related to this. The inputs were research content, velocity of impact, impingement velocity, loading size. So assign weightage. What is this weightage? Let us understand by taking some analogy. Okay? See. Now, during this time, 8th and 9th September, when we are organizing this workshop, the film halls are still not open. They will be opening soon once the situation improves. These things will open. Now, consider yourself as a decision maker. There is a new film on the film hall has opened, situation has improved. Will you go to watch the movie or not? Yes or no? That decision you have to take. Now, on what factors it depends? Yes or no will depend on with whom you are going to watch the movie. With whom? We have taken like three categories. With whom? one is your boyfriend or girlfriend, one is your common friends, and one is with your parents, and one is with neighbor. So this x takes a value of 1 if you are being accompanied by either this or this or this. Otherwise it is 0. This x takes two values, 1 or 0. It is 1 if any of these is accompanying you. It is 0 if something else, like a stranger, although you are moving around. That is, x takes a value of 0. Now, when we are assigning x is our input, it is either 1 or 0. In this particular case, we are giving some weightage. If we are being accompanied by our either boyfriend or girlfriend, we are giving a weight of 10. If we are being accompanied by 4-5 close friends, we are giving a weight of 5. If we are getting company from our parents to us that maybe, then we are giving a weight of 2. Okay? This weight assignment we are doing based on previous learning or based on our experience. Okay? Now there is another input parameter, how that will be influencing our decision. Do we have our own conveyance, whether a car or a bike, own conveyance, then we are giving a weightage of 5. If public transport is available to go to that multiplex, then we are giving a weightage of 2. This weight assignment we are doing based on either our experience, okay, or some relevant knowledge, or also it can be done randomly. But we are not taking random weight assignment right now. We are giving these weightages based on our experience. Now, how much money I need to spend to watch that movie? If it is 0, I don't have to spend. Somebody else is spending, then I am giving a weightage of 5. And maximum rupees 1,000, okay, that I am giving a weight of 2. In between, that is weight of between 2 to 5. And if I have to spend more than 1,000, I am giving a weight 0. Means there is simply nothing like this. This Z value becomes 0. If it is going to be more costly than rupees 1,000. Now, how did weightages are playing a role in our decision making? Let us see. The decision making, D, whether I will go for yes or no, D can be either 1, yes, or can be no. That is value based on W1 into X. X can be 1 or 0, then we W1, weightage 1. Plus W2, Y. And plus W3, Z. Set, and we have set a threshold that if total value of D comes greater than or equal to 10, then we shall go to watch the movie. Okay? Now, let us consider this situation. I want to go with my parents. So X is 1, I am going with parents, weightage is 2. So what is the result? 2 into 1, 2. Then I have got a public transport available. Then again, we are getting like 2 multiplied by 1, so 2 into 1, 2. Here also 2 into 1, 2. 2 plus 2, 4. And here I am getting that I don't have to spend, my father is spending. So Z is 1 and W3 is 5. So what is the result? 4, 2 plus 2, 4 plus 5, 9. Set a threshold, and threshold is greater than equal to 10, then my decision will be yes, otherwise my decision will be no. So in this case, parents are going, I am going by a boss, I don't have to spend. Still then, my decision will be I will not be watching that movie. Now consider another case. The movie is there. My girlfriend is proposing that let us go to that multiplex. So I am giving a weightage of 10 here. His girlfriend proposes. So 10 into 1, this becomes 10. I don't have any convenience available. I do not know whether public transport is there or not. So what happens to y? Y is 0. Y is 0. So this becomes 0. And I have to spend rupees 2,000 if I am going with my girlfriend. Then 0 also becomes 0. Then what is my result? 10 plus 0 plus 0. But my threshold is I will make a yes if our output value is greater than equal to 10. Now this D is 10. Therefore I will make a yes. This decision making when we do that depends on our weightage assignment. We have assigned a very high weightage to this small girlfriend. Suppose I reduce the weight here, then my decision value will change. This weightage assigned to input parameters plays significant role on the output, right? After assigning weightage to input, we have to make a decision, activate and get some output. In case of the particular research question that we are taking, we have already seen that the output is not linearly related to input. Output is non-linearly related. If I do this function like W1 x1 plus W2 x2 plus W3 x3, then I am linearizing the things. Now, in the manufacturing research, this research question that I am handling, I do not have any evidence that it is a linear relation. So how can I take that relation? I cannot take. There are questions where I can take a linear relationship. But in this particular question, I cannot take a linear addition. So the activation must be done so that the linear function that I got can be non-linearized. And how to do that, we are going to see a bit later. And we shall get some output. After what we got, we assigned the weightage to input, we activated that and we got an output. Now once we get this output, applying some activation function, what I shall do is, this output will be your erosion rate. Now compute error. We have already assigned some weightage, random weightage say, or say non-weightage or exponent weightage. After that you got some output. That output may not be equal to the experimental output. What will be the error? The output that is generated by the model minus the output generated by the experiment. That is the error. Now, once you get the error, you find out the mean square error and find out whether this mean square error is minimum. If it is minimum, then your weightage that we put are correct. If they are not minimum, what we have to do? We have to again go for another iteration, another epoch, so that weightage will be taking a different values. So what we are doing? We are taking weightage of the input parameter, we are assigning some weightage, we are activating that linear output, we are getting a non-linear function as output, we are calculating the error with the model output and measure output. And if the error is minimum, we are taking the weightage. If the error is not minimum, then we are changing weightage. Either we may increase weight or we may decrease weight, and we go and see at what combination of weightage this error is minimum. Now, here let me tell you what is your square error kind of thing. Suppose the model generated output, after we assign weightage like A, B, C, some numeric value, some numeric weightage we assign, we got a model output, model generated output of 24, and the actual output that we obtained by experiment is 19. So what is the error? 24 minus 19, that is 5. We use the term square error. this square error will take care of whether we are getting a negative error or not. So this, if my weightage selection is ijk, then the model generator output is 13. The experiments are giving 19. Then our error is -6. If I take average error, 5 plus 1 plus -6 will be 0. But that is not the correct picture. Here you can take, when you are taking a square error, that will give you a better functionality to my model. Therefore, we compute mean square error. We are going to illustrate how to compute mean square error when we develop that SL model. So that is the artificial neural network. Artificial neural network is a computing model which is analogous to biological neural network. In a human brain, we take decision based on lot of perceptions we have, gathered through senses and compiled and what we can call modulated by our previous learning. What we mean by this? So we now see that this thing and we tell that this is pain. We see this, with my eyes see this, these are the sensors. These sensors sense this. Sense some say, how do I know that this is pain? Because of my previous learning. Okay. So this thing happened in the artificial neural network. This is the computing model analogous to biological neural network. Biological neural network means sensing will be there, perception will be there. Okay. And then my decision making will be there, feedback kind of thing. Is this a pain or is this a stick? Oh, this is a pain. How I get confirmed with this can write, then this is a pain. So there are a lot of things, and these things, whatever the decision making process was involved in the brain by our sensory, what you can call actions, neurons, those things, these terms have been modeled artificially in an artificial neural network. Okay. Therefore, and what it looks like, what is the architecture of this? Architecture, how it looks like. The neural network, when we represent, it looks like one is called a input layer. These red dots you can see, whatever input things we do. In our particular research question, what we do? Velocity of impact, rise of content, improvement velocity, event size. These things are input and this layer is called input layer. And the erosion layer is your output layer, this outside. But inside this input layer and output layer, lot of other things happen. See, my eye saw this, but how did I identify this is a pain? Because there are some information processing is going on inside the brain. And in this neural network, what we are doing is, we are non-linearizing these input parameters and we are trying to get some output and we are changing the weightage so that my output will be closely matched with the experimental output. What are the application areas of artificial neural network? Many. We shall be taking some simple subsets of application area. One is your pattern recognition. Pattern recognition in artificial intelligence is of quite significant use. One of the examples that we see here. Here you can see this type of quiz question comes in our social media pages very frequently. Although these were also coming in our film magazine like Stardust Film, identify the heroines. Can you identify who is she? Just see it very closely. See, I can see that she is Madam Kareena Kapoor. Okay. And probably you can guess correctly. Look at this. But in artificial intelligence, see, There are many applications, like in your mobile there is the application called face recognition. Even in the entire photo where 100% from two dogs stand, the artificial intelligence demands that identify the dog. Now artificial intelligence demands that identify who is this heroine or who is the person. How do you do that? That is called a pattern recognition. Can we generate a profile of the eyes or nose or the nose or some person so that the profile can be matched with respect to, suppose we take a small area, count the pixels, where this is dark, where this is bright, formulate a matrix for these eyes, then map it, so the non-human size. If the mapping is proper, then I can tell that yes, she is Madam Kajar, or she is Madam Katrina Kaif. Pattern recognition. What we did, we match the strip, match the profile of brightness, darkness, pixels, and whatever, the reflections that are coming up, the color sense that is coming up, and if that profile matches with a known photograph, then we can tell that yes, wherever this profile is present, she is Madam Kajar. Pattern recognition. This is one area where artificial neural network plays a significant role. This artificial neural network can be used to identify whether the currency is fake or correct. That also we can do by again taking these pixels, the brightness, the proportions, whatever are there in these currencies. Another application area is stock exchange prediction. You know, the stock exchange, especially the share value, the mutual funds, these details that money grows exponentially when we invest in shares. What people take. And we have seen several people almost going bankrupt. How? Because stock exchange prediction is a very, very, very difficult and intricate task. We have got highly experienced financial advisors who are also not predicting 100% correct result. In these cases, why this is happening? Because there are so many parameters which influence a company's share to go up and come down. And with so much data, it is very difficult to analyze if we are using our own perception, our own analysis, our own looks on this. But using artificial neural network, this can be easier. Okay, stock exchange prediction. Another is your healthcare management. One is diagnosis. That also people are doing in healthcare management. The major part. Say, fever. I am having a temperature of 101 degree Fahrenheit. So what does it mean? There can be numerous regions, 100 plus regions. So how do I know that whether this is fever caused by virus 1 or virus 2 or virus 3 or bacteria or what? So there are again several set of input parameters which are essential, and this artificial neural network also finds wide application there also, especially in cancer diagnostics. Okay. In manufacturing process control, like which parameters are to be changed so that the quality of output remains within acceptable limit. There are so many process parameters. When you think of a product, the product goes through a chain of workstations. In each workstation there are so many process parameters. Now, a lot of process parameters have to be controlled. And in what way they should be controlled so that the output matches the required quality. If there is some error, then which parameter is to be controlled? There also you find significant application of artificial neural network these days. Now, considering the terms that we are to be acquainted when we discuss artificial neural network, one is neuron. Neuron means each of the, say, in the input parameter, whatever we do, like your velocity of the impact is 1 neuron, your impingement velocity is angle is 1 neuron, Lysis content is 1 neuron, right there. And there is output layer erosion rate is 1 neuron. And I told that there is hidden things neuron, information is being processed. That means we are taking vector form and activity to get these hidden layers. Each of these is a neuron. This is a neuron, this is a neuron, this is a neuron, this is a neuron. How many neurons are there? You can see 4 plus 4, 8, 3, 11, 12 neurons. And when you are handling large data, there may be hundreds of neurons. Okay. And to each neuron, say consider this neuron. This neuron is getting fed from this, from this, from this, from this. And each of the connections is having some weight. We have talked about weighted connections. Okay. So from this neuron to this neuron, it is connected with some weightage. From this neuron to this neuron, it is connected with another weight. From this neuron to this neuron, it is connected with another weight. From this to this, it is connected with another weight. So here we have got 4 weights. For this we have again 4. For this again 4. So 12 weights are there. 12 weighted connectors are there. I want to see. And here also another 12 weighted connectors you can find. 12 plus 12. 24. And here we have got 4 connectors because there is only 1 neuron. This neuron is getting fed from this 4 neuron individual. So there are many weighted connections available. This is called input layer, these are hidden layer, and this is output layer. We can have a single hidden layer or we can have more than one hidden layer. Okay. This is a very important term called perceptron. And in this session we shall know how a perceptron is to be analyzed. What we mean by the perceptron is, look at our previous drawing. Consider this. This is being connected from this node, from this neuron, from this neuron, from this neuron. Okay. Now I am expanding this particular one, and we are taking it here. These are input things, input neurons. Here in this particular drawing, we are taking 3 input neurons. X1, X2, X3. We are given weightage to our input, W1 X1 plus W2 X2 plus W3 X3. There is a summation, W1 X1, W2 X2 and W3 X3. Further, we need to add a bias of known quantity with a known weightage. Okay. This, what is the use of this, we shall be having a better idea when we develop a real model that will help us. Okay. Now currently let us think that the perceptron consists of the input parameter with weightages W1, W2, W3 and a bias with movement. What we are doing is summation. W0 into 1 plus W1 X1 plus W2 X2 plus W3 X3. We are getting this. Now we shall be activating that. We can be non-linearizing that to get the output value. What is the non-linearization or activation function? Let us see. We can have different activation functions. Several activation functions are there. We are taking 3 activation functions for this particular example. Or for this session. One is a binary step activation. Binary step means once we reach some particular value, the answer will be either 1 or 0. We are not going to consider that for this particular example. We are going to take sigmoid activation, that is f of x equal to 1 divided by 1 plus e to the power minus x. Let me explain the sigmoid activation first. After that you can do taking tan h activation, we say tan hx. What is this? Let us take an example. Here we have taken that single perceptron. We have got 4 input parameter. I have taken a value of 0.25. No input parameter 0.5, 0.25, 1.0. With some voltage I have assigned 0.02, 0.03, 0.04, 0.05 and bias I have taken a 0.1 with a voltage of 1. So I can compute here as 1 into 0.1 plus 0.02 into 0.25 plus 0.03 into 0.05 plus 0.04 into 0.75 plus 0.05 into 1, and I shall get a value of 0.2. Now, activation I am using sigma function means 1 by 1 plus e to the power minus x, x is 0.2. This sigma function, what we write? Fx is 1 by 1 plus e to the power minus x. What is x? X is this value 0.2. 1 divided by 1 plus e to the power minus 0.2. When I do that, I shall get an output function of 0.546. Okay? Did you see what we do? Now in the artificial neural network, what happens? There is not a single perceptron. This is one perceptron. I got a value of 0.56. In this perceptron, I may get a value of 0.74. In this perceptron, I may get a value of 0.6. In this perceptron, my inputs are from these nodes now. From these neurons. 0.56, 0.74, 0.62. I shall get another one here. Okay, let me take that. I am getting value 0.82. By doing what? Again, vector summation. I shall again give some weight. W4, W5, W6. W4 into this value, W5 into this value, W6 into this value. I shall get some X. Again I shall activate using a sigma function. 1 by 1 plus e to the minus x. I shall get this value. Okay. And from these, I shall again apply vector summation and activation to get output value. I shall get some numeric value of output. Now with this output I shall compare my experimental output. So our strategy is involving what? We have to determine the vector from which the model output matches the actual output. And you saw how much computation is necessary. This is computation intensive thing. With advancement of computers, this process has now become easy. And once we develop that Excel coding, you can see how in some minutes we can find out what are the vectors for the function to be generated. Okay. So the discussion that we had right now is we conceptualize what is artificial neural network, what are the application area, what are the terminology, what are the steps involved, and we shall be discussing the model development in Excel. But here is a quiz for you. Kindly see the questions very carefully and take 10 minutes to solve this question before the part 2 comes up. Thank you.
The concepts and terminology related to artificial neural network. In this session, we shall be discussing on how to utilize those techniques, those concepts into modeling through artificial neural network in the platform of Excel. Okay. To start with, we have to ensure that we have got solver array that is available in the Excel, and second step is the data that we are handling, whether they have already been categorized into learning, validating and testing category. What we have to do in the Excel, we have to generate our program in such a way that our data space, Excel is nothing but what you can say, it stores data in different, in a lot of arrays, a matrix kind of thing, okay. So in the Excel, we have to create our file in such a way that it will have proper space for data, proper space for weight and bias that we shall generate, proper weight for perceptron matrix. All these spaces are to be created in the Excel file. Okay. After that, what we have to do? Using the solver, we shall solve for the artificial neural network and interpret the result. These are the basic steps. We know that you are very conversant with Excel, but still then we need to specify this, that in Excel, each of the cell has got some ID which is specified by this column. Say this is A, B, C, D, and the rows here 3, 4, 5, etc. You can see that the cursor now is in this position, which is identified as D4, 1, 2, 3 and 4. This space is D4. In the Excel, all the cells will be addressed by their cell ID, that is stated by column number and row number. This is very important, and I understand that you all know this, but the entire coding, the modeling depends on proper storage of the cell ID in our programming space. Okay? We need a solver. If your computer Excel has a solver or not, you can clearly check. You have to go to the data bar of this Excel. You will see that there will be something called written here solver. If it is not there, then that you can add in using that Excel software itself. Here at this position, if you click, then it shall come with Excel option. You go there and you can add in the solver. And we need that solver in order to solve any kind of modeling problem, be it artificial neural network or a transportation or assignment problem, as you have seen in operation itself. Okay, in simplex problems also. So what does a solver do? When we select the solver, we shall get a platform like this. We shall see something like this. It is called set target cell. In an artificial neural network, what we are doing? We are varying weightage so that mean square error is minimum. So our target cell is some cell which stores the mean square error that we compute. Here we have written AB3. AB3 is that cell in my Excel file which has mean square error. And what we have to do? We have to minimize that. Okay. By changing weightage we can give in hidden layers. We have already discussed in our ANN concept that we go on changing weightage to each of the input parameter, or even from each of the neuron, that is from the hidden layer to output. Those are the weightage, and bias also. Most of the time we give the bias. Otherwise also this solver has a platform where you can change the bias too. Okay. So these changing things, the weight, wherever in the Excel file the weight will be stored, we have to click those files, we have to select those files so that those cells will be changed in order to get the minimum error, minimum mean square error. That is what the logic of artificial neural network is. So in the solver, our target cell which contains mean square error is to be minimized, and we shall get changing the cells which store the weight. Okay. After we click the solve, we shall get the answer. In the solver you can see there are options also. What are the options? How much time the program will run, how many iterations. Iteration means each time it changes weightage, it computes mean square error. Whether the mean square error is minimum or not, it will again go on changing weight to evaluate whether mean square error is still minimum, it is decreasing, or it has started increasing. So depending on complexity, the number of iterations will vary. For simple problems, the iterations may be 20, 30, but if you are handling a more complicated kind of problem, where data is quite large, you may need more iteration. It is not necessary that iteration will be proportional to number of data. Depending on the complexity of the relation, the iteration may vary, and sometimes you shall see if our choice, if our selection of hidden layer neuron, number of neuron and number of hidden layer is not proper, the solution may not converge at all. In that case, what we have to do? We have to change our architecture of the neural network. We have to change the number of hidden layers, we have to change the number of neurons in the hidden layer. Okay. So, this problem statement we already have offered in our session 1. It was related to erosion test, where erosion rate of the composite was obtained experimentally by varying velocity of impact, content of rhizoscreen, weight percentage, impingement angle and erodent size. Okay. Based on that we give a data set also, like for test run for different velocity of impact, for different rhizos content, what are the erosion rates. Okay. And we are working on that. Now you have to start with again this cell ID identification. We know that this is my A column, this column is A column, this I have merged everything, therefore this is 1, this is 2. So this cell is A2, this cell is B column, third row, so B3. If you go down, the last one is B18. So all the data are from B3 to B18, C3 to C18, D3 to D18, E3 to E18, and here is the output erosion rate. Okay. The cell ID is quite important. Now what we are doing in the first step is we are normalizing data. Normalizing means the data, those were available in different terminologies, say 45, 60, 75, 90. Now we are reducing it in the scale of 0 to 1. How we are doing it? Say, this is my H column in the Excel file, ABCD were for this ABCDE, everything was for the input parameter. We left one cell bank G column, and now here this is H1, 2, 3, H3. Here we are typing this is equal to. Whenever we type equal to, that means we are entering a code equal to B3. B3 was the data velocity of impact in the experiment divided by maximum among the data that were contained between B3 to B18. Kindly see how it is written. B3 divided by maximum of all the data which were stored between B3 to B18. Okay. Once you find this, in the Excel you can drop down quickly so that you can fill in all these data. All 16 data will be filled up. Similarly, for this, what we shall be writing? This is equal to C3 by maximum C3 to C18. Here you can see we have imported dollar sign. Why dollar sign? If this cell will be copied here, then this will automatically change from B4 to B19. In order to fix it between B3 to B18, we need a dollar sign. Okay. B3 by max, B$3 to B$18. Similarly, this will be C3 by max, C$3 to C$18. And similarly, we can fill in all this data. Okay. This is normalizing. This step we have to do. This is in H column, I column, J column and L column in my Excel file. Okay. Next step is to propose a neural architecture. How many hidden layer and how many neurons? There is no specific rule. No specific rule. How many hidden layers will be there or how many neurons will be there in each hidden layer. So we are selecting one hidden layer. In one hidden layer, how many neurons will be there? 4, 5, 6, 7, 8, 9, 10. It is usually seen that if number of neurons are more, then our accuracy is better. But sometimes what happens is curve gets overfitted. In that case, we generally lose a lot of efficiency, efficacy in the computational system. What we want is curve should fit. It should not be like over computing. Each time we are computing, We are not handling only one question, there are so many questions, and all these are needing the computational intensiveness. And sometimes in level fitting, what will happen is we tend to interpret the things in a different way. So selecting the neuron means it is basically hit and trial kind of thing. Basically, you go with say one or two hidden layers. In each of the hidden layers you pick up some neuron. It has so from experience we can see there are several persons who are giving thumb rules kind of thing that take two hidden layers. In first hidden layer take almost neurons which is 2/3 of the input parameter. There is no specific rule, but yes, for a thumb rule we can try with one hidden layer, 7 to 8 neuron, see the result. If it is converging, if your accuracy is okay, if your error is minimized, then go ahead with that. If this is not coming, if error is more or set is not converging, then change the number of neuron. Or if still it is not coming, then go for second hidden layer. Okay, that is how we shall proceed. Now here we are proposing a neuron of this my input layer has 4 nodes. 4 nodes means Rice's content is there, velocity of impact is there, impingement angle is there, and erodent size is there. In the output erosion rate, only one is there. In the hidden layer, this is our option. Now, because computer is going to handle, therefore I have taken 10 neurons. You can start with 4 neuron, 5 neuron, 6 neuron, 7 neuron, something like that, and the number of neuron at which the accuracy is coming best. If error is coming minimum, take that. Currently, there are several softwares that are combined, say genetic algorithm with artificial neural network. That helps in predicting the number of neurons that will give you best accuracy, but still then that is also a heuristic thing. There is no logical reasoning as such to derive the number of neurons that should be there. So we are taking like 10 neuron in the first hidden layer, or one hidden layer in the neural architecture we are taking. You can also think of second hidden layer, changing the number of neurons, and that you are free to do. That is what research is all about. Do some changes and find out which model fits you. Now here, in this HIJK we have given our normalized after that from M we are starting like weight assignment, and these weight assignments are random. Weight assignment are random. And how many we have taken, kindly see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Why? Because we are thinking of 10 nodes in one hidden layer. This is for the hidden layer, the weight assignment, and we have got 10 nodes, so we have to fill in 10 weightage for each parameter. There are 4 parameters. So for parameter 1, 10 node, for parameter 2, 10 node, for parameter 3, 10 node, for parameter 4, 10 node. Where it comes, let us see. Say this is my parameter 1. So how many nodes it will be connected? 1 to 10. So we need 10 weightage for parameter 1. Similarly for parameter 2 again we need 10 weightage. For parameter 3 we need 10 weightage. For parameter 4 we need 10 weightage. So this is what we will be assigning some random value initially. We may leave it blank also in Excel. Once you leave it blank, it will read as 0. And we can give a bias value that we are fixing. We may also allow Excel to select bias also. If I leave it blank and choose it as a changing cell, that will also be done. But as such by logic, we are going to see bias changes from 1 to 2 to 3, how my data will be varying, how my output will be varying, therefore we can give a number to bias. Okay. So in M3 we have started this weight assignment. This space is to be left for the weight and this is for bias. Weight means M3 up to M3, 4, 5, 6, it means 12 to M and OP. So M3 to P12 we have to leave it for weightage, and this Q3 is for bias. Fine. Now once we are doing this, then we are going for computing the perceptron in each of the neuron in the hidden layer. There are 10 neurons in the hidden layer, and here is neuron 1, neuron 2, neuron 3, neuron 4, and we have got all 16 set of data. So for each one we need to compute the perceptron. Perceptron formula we have already seen. That is 1 by 1 minus e to the power minus x. 1 by 1 plus e to the minus x. So what was x? X was sum of weighted products. You can remember this in the session 1. This is what we are doing. Sum product of H3, K3. Those were your normalized data. M3, P3. Those were your assigned what we can call weightages, M3 to P3. So what we did is input multiplied by weight. We did this. Weight into input. Okay. By performing this command, we are doing like S3 will be multiplied by M3 plus, I3 will be multiplied by N3 plus, J3 will be multiplied by O3 plus, and K3 will be multiplied by O3, P3. This is the sum of weighted products and minus bias. You can take plus bias or minus bias, that is open to you, that X. So 1 by 1 plus e to the minus x is the activation function, sigmoid equivalent function, and that we are using in this, and we can draw down. While dropping down, the data set change, therefore we have to use these dollar signs very judiciously. That while doing this, this M3 to P3 will be multiplied here, okay, and when we go down, when we calculate this column, the second column, what change is there you can see. Instead of M3 to P3, we are taking second row of assumed weightage. In the weightage column, M3 to P3, there was one weightage for first neuron. In the second row, there was weightage for second neuron. This is my second neuron. So that is for M4 to P4, and that's what we have to do. Here what we have to do? We have to take the same thing, but we have to change M5 to P5. Bias value will remain same, that is fixed. Both $2 are there, that cell is fixed. So if I perform this command, I can fill in all these data by perceptron functions. Okay. Next, what we have to do? If I am taking one hidden layer, from one hidden layer we have to go to the output layer. In first hidden layer we have taken 10 neurons. So from each of the neurons, that will go to the output node. So there will be 10 weightages. Fine. And a bias. And we have to keep a space and keep that space blank. Or you can assign some zero value or initialize this, but in Excel we advise to keep it blank. And in a bias you can give any number whatever you like. Okay. Now, coming to the this is what is output. What is the output? Output is evaluated from the perceptron value considering the sum product and of what? The neuron value in the hidden layer and weightage. We can find out the output here as generated by the model. That is my model generated output. And in the experiment we have got certain output. The error is this minus this we have taken. Model output minus experiment output, or experiment output minus model output, we can take as error. So here we have taken the experimental result divided by model result as the error, and this is what is the error. Okay. And from which we have to calculate the mean square error. Whatever errors are there, what is the command, let us see. Mean square error means all the errors will be squared and taken the average. This is sum square of those error range 83 to 8013, we have taken 11 data for validation, divided by number of data, that is 11, and we can calculate mean square error, and this is the initial result by taking all weightage 0. Now weightage will be changed, and once weightage will be changed, mean square error will be different. What we want, that this cell is to have the minimum value, and for what set of weightage. Okay, this is something we want. So let us go to solver. Number of target cell is mean square error cell. Set it to minimize. By changing cell, select those cells where weightages are there, which need to be changed, and then click solve. Once you click solve, you can give solve options, you can change the number of iterations if you like, and once you do that, your result will straight come. And you can see what is the error now. 7 into 10 to the power minus. So low an error. Okay. That means what? My model output data and experimental output data will be very close, and you can see this yourself. The error is quite low. That means we have generated a model which is giving a output which is extremely close to experimental output. And this is for learning purpose. Now whether this model is okay or not, in order to do that, we have to validate the model output again with the result of output for another 3 cells. For validation you have kept 3, and experimental output also you have got. If you get low error there, then our model is correct. If you do not get low error there, then you have to again change the number of neurons. Okay. Say from 10 to 11 now, like that you can go, or you can consider adding a second hidden layer. That is the entire logic of artificial neural network. Fine? So once we do that, the solver will also return for what weightage this MSE is minimum. Remember in the solver what we did? We changed the weightages. By changing weight, we got the minimum mean square error. So once you do the solver calculation, you shall also get the weightage for the hidden layer, output layer, first hidden layer, second hidden layer, whatever. We allow the cells to have change value, we can get the different weightage for this. This is what is the beauty of that Excel file. You can see that in different software you will see that is in a black box. Software will give you the output result only, that this is the neural network and this is the output. But in Excel, when you will do this, you will find out all these weightages, and you have got liberty to go in changing something, say changing bias, changing some weightages, also to see the impact, how the result vary. That is basically a grey box kind of this, no black box that is there in the software. So what you have to supposed to do? You have to include validation data. If error is acceptable, model is okay. If error is not acceptable, then change either change the architecture. Either go for a different hidden layer, or you go for different number of neurons. Fine. Once you are through with the model, then what results have to be reported in your research report? One is neural network architecture, the drawing. How many neurons are there, in how many layers are there, how they are connected. This. Second, after running the model, how much is the mean square error you have got? That is to be reported. Another report usually journals may ask is number of iteration versus accuracy. For 10 iteration, what is the accuracy? For 20 iteration, what is the accuracy? In the solver you have seen, you can fix the number of iterations, that is epochs. So once you restrict that to 10 iteration, you can get what is the error. If you change that to 20 iteration, what is the error? So you can generate a graph between epoch and accuracy. And interpretation of the result. In the very initial session we have discussed, artificial neural network can be helpful in predicting different things, at what parameter it can be optimized, or which parameter contributes to what extent, or if I change the parameters to different value, what will be my output. Those are the interpretation. And some of the research journals also ask sensitivity analysis report in the server output that will ask you answer report, sensitivity analysis report and limit report. You have to find that and interpret the result. Okay. So what we discuss now is how to prepare artificial neural network model in Excel. What you are required to do is, we have delivered, you have been informed. Now, in order to learn properly, you have to validate that whether you have known or not, you have learned or not, and in order to do that, I allow you to take this particular quick test. I have stated 20 minutes, but yes, you can take 30 minutes too. Okay, thank you very much. So respected participants, I am Tanmay Mohanty. Namaskar to you. I will be taking your queries if you have on this session of ANN using Excel. If you have anything to ask, you may please raise your query. Is my voice audible?
Yes, sir. Audible.
So, thank you. I hope that you have attended these two videos, you have seen this. There were some audio issues interimly, and I have requested our coordinator, Professor Trupti Mahapatra, to share the videos with you so that you can see that in your leisure time. And you can also practice those two quizzes that were attached to this videos earlier. But while listening, if you have got something in your mind, I will be obliged to answer you. Please go ahead with your queries.
So, sir, great things, great learning, and all the technology, whatever you are saying through Excel, we can make a good model also. So, great learning. Like, new
Thank
things, Excel can
you.
also provide such a beautiful platform. So, that is great learning from this. Thank you, sir. Thank you for your support
There
and
are
for your time.
internationally big companies. So internationally big companies are there, including aeronautic aircraft manufacturer, which still rely on Excel coding. Excel is what you can tell. It is a visible MATLAB. MATLAB does the matrix calculation. Excel also does the same. MATLAB needs some programming skill. Excel needs only your logical strength. Yeah. Any other queries from your side, sir and madam?
Participants, if you have any other query, you can go ahead. Sir, I don't think there is much query from their side.
Sir, I will request you, sir, those participants who are interested to get these videos from you, kindly note down their mail IDs and share with me so that I can share the link with them also.
Yes, sir, I will do that. Definitely do
Sir.
that. Sir, we are very much
And
thankful
thank
to you
you.
for accepting our invitation within a
I
very
am
short
thankful
span of
to
time.
you.
Sir, I am extremely sorry
I am
because due
thankful
to
to
one
you.
urgent meeting, I have to come to Vice Chancellor's chamber, so I was unable to be online at this time.
It is fine, sir. It is fine. Actually, I am thankful to you, our Professor D. Misra, Professor Arun Rao, Professor K. Pal, other colleagues, and I am thankful to all the participants who are sparing their valuable time to attend these webinars and sharpening their learning. I hope that learning in true sense happens, and thank you very much for the opportunity provided to me. Thank you.